Hello students and welcome to this lecture on optical isomerism. Today we are going to see the RS nomenclature of optical isomers that is adopted by IUPAC. So let us begin the lecture, but before that let me tell you that if you like the lecture, please hit the like button, subscribe, and hit the bell icon. When you do that, you will get intimation of the further lectures which are shared. Okay, so let us begin with optical isomerism. The third lecture, last lecture we saw the DL notation. Now let us begin with the RS nomenclature. Okay. Uh, Before we see that, we need to understand the 3D representation of the chiral molecules. Because if they are represented in a 2D structure form, you will not be able to nomenclate them properly. So, there are various methods. For second year purpose, we are going to see two representations for RS nomenclature, and two more representations we will see later when we study conformations. So, the first type of representation is dotted line wedge structure. Here, dotted line is the bond that is pointing backwards. Please try to understand that this dotted line is not used. Okay, the dotted line that is used is something like this. Why? Because the first type of dotted line may indicate bonds that are partially broken, which we are not using, and so this dotted line, a different type of dotted line. Ensure that you use this dotted line. Now this is a sp3 hybrid carbon. How does a sp3 hybrid carbon look? Three valencies directed like a tripod stand. If you see, these three valencies are directed like a tripod stand, and the fourth valency is directed upwards. It can be reverse also. Three valencies directed like a inverted tripod. In that case, the fourth valency is pointing backwards. Now, dotted line is this, wedge is a thick line. Okay, so there is one dotted line, one thick line, and two straight lines. The other two lines indicate the bonds which lie in the plane of your paper or on my screen or the blackboard. Whereas the wedge or the thick line indicates the bond that is coming towards you. And the dotted line indicates the bond that is going away from you. I hope this part is clear. These two lines indicate the bonds which are in the plane of your paper notebook or in the plane of my screen. The dotted line indicates bond that is going away from me. Here, shown here is not exactly going away from me, but it is actually going away from me, and this bond is coming towards me. This is not in the plane of the screen or not in the plane of your paper. Okay, when we understand that, if there are molecules with two adjacent chiral carbons, this is the representation. Okay, more about this we will see in conformations, but this is the representation where the tripod stand is sort of facing your left. This is the vertical line, and here the tripod stand is facing to your right, and the same vertical line is shared. Now, a Fisher projection formula are one vertical line and one horizontal line. Here, PQRS indicate the substituents, different substituents. As we saw in the previous lecture, a chiral carbon has four different substituents. Okay, so these are indicated by PQRS. Here, if there are two chiral carbons, The vertical line remains same. One more horizontal line is added. Okay. You will get used to these formulae as you study further. So look at the 3D representation. This is the 3D representation of the molecule in a dotted line wedge structure. I hope everybody can see this. Okay. So this is the representation in the dotted line wedge structure. This is its mirror image, if you see. Okay, so this is one isomer, this is another optical isomer. Okay. The same is converted to Fisher. Now just see how to convert this to Fisher. There are two ways to convert a dotted line wedge structure to a Fisher structure. In a first way, you imagine that your eye is in between the dotted line and the wedge. So you are looking in the plane. So what happens? CH3 becomes on your left. Do you realize this? If you are looking like this, CH3 is on your left and H is on your right. Okay, so that is what is done over here. CH3 is on my left here, H is on my right. Cl is pointing upwards, and so Cl is on the vertical line. See, whichever substituents are on the straight line are always on the vertical line. And whichever substituents are represented by dotted line and wedge are always on the horizontal line. As against, and you have to look in between the dotted line and the wedge structure. Okay. So now the second isomer. This is the dotted line, this is the wedge. So you look in between these two, like this, towards the molecule. So now you are looking like this. So if you are looking towards the carbon like this, CH3 is on your right, correct? And H is on your left. So write CH3 on your right and H on your left. Okay. There is another way of converting a Fisher structure to a dotted line wedge structure. I'm not very good at drawing, but just try to understand. Forget about these fingers. The first finger represents is pointing towards the vertical line, Cl. Obviously, when you hold it like this, the second finger, I'm very sorry for this, but in the screen that you are seeing a mirror image. But you try to hold your hand in this position. So this finger is pointing towards chlorine and your thumb is pointing towards COH, right? If that is the case, then just see how you are doing converting this. So obviously, like this, the vertical COH and Cl will come on the vertical line. And Cl is pointing upwards, it remains pointing upwards. COH is pointing downwards, it remains pointing downwards. You hold your finger like this. Now, in this situation, the thick line is always directed towards the thumb. The thick line substituent is directed towards the thumb. So it is going to be on your right. The remaining substituent is directed on the opposite side of the thumb. So it comes to your left. Look at this. Now here, this is the finger. You are going to use your right hand over here. For this structure, you are going to use your right hand so that, see what happens, this finger and there are other fingers and your thumb is pointing like this. Okay. So You are going to use your right hand for this, and you are going to use your left hand for this particular structure. You are going to use your left hand. It depends upon what is the direction of the two straight lines in plane lines. Here you are going to use your right hand. Okay. So you wrote Cl and COOH. Okay. Now, what is the direction of the thumb? Towards your left. Correct? If the direction of the thumb is towards your left, you have to put the thick line or the wedge substituent on the left and the dotted line or the substituent on the other side. I hope this is clear. I will repeat again. Look at the two lines in the plane of the paper or on the screen and hold your hand such that other fingers point upwards and the thumb points just like the COH. Okay, so you will require your left hand for this. When you do that, write Cl and COH on the vertical line and thick line substituent or the wedge substituent will be towards the direction of the thumb. Okay, so it is going to be, since the direction of the thumb is like this, it is going to be here. And opposite way, for putting your finger and thumb on this, you require your right hand. With left hand, you cannot do that. So put your right hand. The COH is pointing downwards and towards left, and so CH3 points towards left. You can use any one of these two tricks to convert a dotted line to fissure. Now, coming to IUPAC nomenclature, R and S nomenclature. Okay, R and S are the prefixes which are used before the nomenclature. Okay, the nomenclature remains same. Use R or S as the prefix. Now, how to decide the prefixes? First point to be remembered is use the Kahn-Ingold-Prelog system of assigning priority numbers. We have seen that in case of geometric isomers. For EZ, we use that, right? Now, same system we have to use for RS. The only thing is in EZ, we assigned priority numbers 1 and 2 because it was a sp2 hybrid carbon. Here, we are assigning priority numbers 1, 2, 3, and 4. Just remember that because to each chiral carbon, there are 4 substituents attached. So, assign 4 priority numbers. Now, after that, things are different. But first step is same. After assigning 4 priority numbers, draw a semicircle from 1 to 2 to 3. Okay, when you draw a semicircle from 1 to 2 to 3, then things are different for dotted line wedge and fissure. Okay, just see over here. For dotted line wedge representation, when the last priority is pointing backwards, it is very easy. Okay, so just see this. Now here, Cl gets number 1, correct? COH gets number 2. Again, I will remind you, the atomic number is higher of Cl than of carbon. You look at the atom attached and not the group attached. The third number will be CH3 and the fourth number is hydrogen. Now, when the fourth number is pointing backwards, there is no other conversion needed. What you do is trace a semicircle going from, ignore 4 altogether. From 1, you go to 2 and then go to 3. Is it clear? 1 to 2 to 3. Now, this is a clockwise direction. Do you understand that this is a clockwise direction from 9 to 12 to 3? So this is clockwise direction. So this becomes R. Look at this. This is its mirror image. Now again assign priority numbers. Okay, Cl is going to be 1. COH is going to be 2. CH3 is going to be 3 and H is going to be 4. Now, fourth, you have ensured that the fourth priority is pointing backwards. So directly trace a semicircle from 1 to 2 to 3. Now, what is the direction of this semicircle going from 1 to 2 to 3? It is anti-clockwise. Can you see? This is anti-clockwise, and so this compound is termed as S. Okay. Have a look at this once again. You know that the fourth priority is pointing backwards. Okay. So first assign priority numbers. Now oxygen gets number 1 because oxygen is attached. Among these two, carbons are attached. So look at the second atom. There is one more carbon. Here there are only hydrogens. So this gets priority number 2. This gets priority number 3. And this gets priority number 4. Now, trace a semicircle going from 1 to 2 to 3. Correct? This is anti-clockwise. And so, the prefix that will be attached to this nomenclature will be S. What will be the name? 2-butanol, correct? This is going to be 2-chloropropanoic acid. Two-chloropropanoic acid. This is R2-chloropropanoic acid and this is S2-chloropropanoic acid. Okay. Now, let us try to understand the Fisher, how to nomenclate the Fisher representation. Here, what you do is first thing is assign priority numbers. So this is 1, this is 2, this is 3, and this is 4. Okay. On the other hand, over here, this is 1, this is 2, this is 3, and this is 4. Okay. After assigning priority numbers, you trace a semicircle. That method also remains same. This is going from 1 to 2 to 3. Okay. This is clockwise, correct? After 9 o'clock comes 12 o'clock and then 3 o'clock. This is clockwise. And fourth priority group is on the vertical line, irrespective of whether it is pointing upwards or downwards, but it is on the vertical line. So, this is clockwise, so it is R. R, just a minute. It is going to be R 2-chloropropanoic acid. Now we will see what if this is on the horizontal line. Assigning priority numbers is done. Go from 1 to 2 to 3. That time ignore existence of 4. 1 to 2 to 3. Okay, ensure that you are going from 1 to 2 to 3. When you do that, this is clockwise, correct? Just like this is clockwise. But fourth priority is on the horizontal line, so reverse the designation. So although it is clockwise, so you will write R, but fourth priority is on the horizontal line, so the designation is S. Does everybody get this? I will solve one more over here. I hope that will help you. This is going to be 4 anyways. COOH is going to be 1 over here because COOH has 3 oxygens attached. If you convert the C double bond O and OH to C, O, O and OH, right? The creation of phantom atom. This is a phantom atom, this is a phantom atom. So, it is going to be 3 oxygens attached. Here, there is only 1 oxygen attached, so it becomes 2. Here, there is no oxygen attached, only hydrogens attached to carbon, so this becomes 3, right? Now, again, forget on which line H is. Trace a semicircle going from 1 to 2 to 3. Ensure that you are going from 1 to 2 to 3. Okay. Now, this is clockwise, right? This is clockwise, so R, but since the H is on the horizontal line, the actual designation is S. Clear? We will solve 4 more in this lecture and then we will end the lecture. Any difficulties that you have, you can mail to me on the mail ID that is given on the first slide. So let us try to solve these 4 before I end the lecture. First one, H is 4, right? All others are higher than H. This is 1. Iodine, much higher atomic number. This is C2H5, so this gets number 2. This gets number 3. Now, when there is a dotted line wedge structure, just ensure that 4th priority is pointing backwards. Okay, so you need not do anything apart from assigning the priority numbers. What you do is trace a semicircle going from 1 to 2 to 3. Now this is anti-clockwise, so it is going to be S. Nomenclature will be 2-iodobutane, correct? Look at this. This is again the same. Sorry. 4th priority is pointing backwards, right? If 4th priority is pointing backwards, no need to convert the structure. Okay, this is 1, this is 2, this is 3. Now, trace a semicircle going from 1 to 2 to 3. This is clockwise, correct? And so this structure is R2-chloropropanoic acid, right? Now come to this. Here, 4th priority is not pointing backwards. So what you do, you convert it to Fisher structure. Now for converting it to Fisher structure, whichever 2 substituents are in the plane of your paper, put them on the horizontal line. CH3 is pointing upwards. COH is pointing downwards. Now look from here. Irrespective of the fact that which method you use, if you look in between these two, H is going to be on your right and Br is going to be on your left. As against that, if you use that hand-holding method, okay, still CH3 and COOH will be like this. Which hand you will be using? You will be using your left hand so that CH3 and COOH are covered in a angle. Okay, now when your thumb is pointing towards right, the thick line substituent should point towards your right, towards the thumb. So it is both ways, it is same. Now, try to assign. This is 4. This is 1. This is 2. Why? Bromine has higher atomic number than carbon. Here, both carbons attached, so second atom attached should be seen. Now, once you have assigned the priority numbers, draw a semicircle going from 1 to 2 to 3. Okay, 1 to 2 to 3. You have to ignore 4. Now, this is an anti-clockwise structure. This is going anti-clockwise. So is, but 4th priority number is on the horizontal line. So it is R. Getting this? Same is the case over here. You can just convert this to a Fisher structure because 4th priority is not pointing backwards. So convert to a Fisher structure. The 2 lines which are in plane, just put them in place. Now here again, you will require your left hand. Okay, so CH3, which is on the thick line, will come on in the direction of the thumb. So it is going to be on your right. And OH will come on your left. As against that, if you try to look in between these two, still CH3 is on your right, OH is on your left. Now assign the priority numbers. This is going to be 1. This is going to be 4. Right? Among these two, this is when there is an unsaturated carbon, there will be more number of phantom atoms created. And so this gets priority over this. Right? Now trace a semicircle going from 1 to 2 to 3. 1 to 2 to 3. This is clockwise. Right? But fourth priority is on the horizontal line, irrespective of whether it is on the left or on the right. It is on the horizontal line. So reverse. So it is going to be S. I hope this is clear to you. Here we are stopping the lecture. In the next lecture, a few more examples I will flash. And then if you have any difficulty in that, or if you want to submit to me your solved problems, you can do so on mail. Okay. So I'm stopping the lecture over here. Thank you so much for a patient listening. Just a gentle reminder. If you like the lecture, hit the like button, subscribe, and also hit the bell icon so that you get intimation for the next lecture uploaded. Thank you so much.